This is Your Face in Neo, my summer internship project where I wanted to integrate facial recognition applications into the Neo platform. I think there's value to this project on two levels. First, it adds value to Neo as a new computer vision application run on the platform. In a sense, it lets Neo see and apply processing for a user with minimal interaction. There's no special buttons or chips needed, it just needs a good glimpse at your face and it'll know what to do from there. I think this project can also act as another proof of concept for Neo in the IoT space. Since I've been here, I've seen that Neo can connect to, sense, and automate a huge number of things and devices. I think the ability to connect to humans and interact with them in unique ways can help support this. This project added value to me as being experienced working in a professional setting. I've been able to learn some of the best practices and contribute code, but it also gave me the opportunity to explore a field of computer science that I haven't touched on before. I've had zero experience with image processing or machine learning, but I did have an interest. And this project really gave me the opportunity to just dive right in. So all of facial recognition in Neo revolves around this one custom block. This is the Find Face block, and it has three main requirements. The first one being what does it see? This is information grabbed through the unknown terminal. Here I'm passing in arbitrary signals which notify the block to open up the video source specified in the block properties, grab a frame of video from that source, and apply some processing to it. The second requirement is who does it know? This is how it gets all of the reference names and facial encodings that it can do processing against. Here I am querying a Rethink database for all of the reference data and then passing that all into the block as one big string, or one big signal. Finally, this block has who wants to know, which is the output terminal of the block. This block is capable of outputting signals that contain the name of anybody identified in a frame, and it has the optional attribute for the location of that face in the frame. Basically saying, I found Tyler in this frame and he is in the bottom left corner. Now under the hood, this block is doing a few things. Facial perception in the human brain relies on a lot of things we do subconsciously, like prediction and characteristic classification. This all can't be done in computing, but machine learning provides us methods that can improve over time and come close to surpassing human perception. My block is run on top of a trained neural network which knows how to grab an input image, find any faces in it, and then create unique measurements for that face. This is a facial encoding, which is represented as a two-dimensional array containing 128 values. All of my reference data comes into the block as pickled strings, which were important for storing into a database, but inside the block they are unpickled back to their matrix forms, and then I do a lot of matrix comparison to take this unknown encoding and compare it with a bunch of known encodings within a set tolerance, and then I output the reference name associated to that comparison. The output looks something like this. So here, Doug's name and reference encoding was passed into that known terminal, and then this video frame would have been passed into the unknown. All the necessary calculations and measurements would have been done to output something that says, I found the reference name Doug associated to the face in this box. Now, I want to go more in depth on a system that does this, and I want to talk about the coffee counter system, which most of you have already seen. This system relies on two Neo instances with multiple services, all communicating information using PubKeeper. The first Neo instance is the Kitchen Pie, which is attached to a current sensor, and it's publishing out current values that the coffee machine is using at all times. The Kitchen Pie also has a Raspberry Pi camera attached to it, and it's broadcasting a live video stream of everything happening in the kitchen. So if you've seen the front dashboard, you've seen this stream. The second Neo instance is running inside of a Docker container on an Ubuntu server. This server has the capabilities to do facial recognition in real time. The first service in this instance is FaceRec, which takes in those video frames off the Raspberry Pi camera and then identifies anybody inside of it and outputs their name. This goes into the coffee counter service, which takes in the amperage readings from the Kitchen Pie and the names from FaceRec and combines them with some logic to determine how much of what beverage an individual has gotten throughout the day. This information then gets passed out to a marquee handler and a Slack handler, which give us real-time feedback. I encountered a few problems with this project, but I think I learned the most by overcoming them overall. There were two different types of problems that I encountered. Some were expected for a project like this, and then some were completely unexpected. The first of the expected problems was dependencies and installations. Facial recognition relies on a lot of packages and programs to run correctly. For example, OpenCV, which I use to process live video frames, can be tricky to install on different operating systems. Things like macOS, Docker, Ubuntu, and Raspberry Pi all have different installation methods, But the solution to this issue was to tough out the installation the first time and then document what worked. That way I would have a shell script that I could run once, and I could populate any Docker container with all the things needed for facial recognition. The second of the expected problems was processing power. Doing facial recognition in real time relies on a lot of heavy processing that not all machines around the office can do. For example, a Raspberry Pi just can't do real-time facial recognition. But the solution to this was to distribute the computing, which Neo provided. That way I could take the Raspberry Pi frames and send them to an instance that can handle the processing, and then that could communicate all the results. The final problem was an unexpected one, which was how to orchestrate communication between sense current and a face. My coffee counter service grew in size and complexity from its initial version to the version here, simply because there were just too many edge cases I hadn't considered. The solution to this issue was to prototype quickly, identify the main problem, and then ask for help. I got a lot of great solutions to this problem by asking people around the office. As for some future ideas with facial recognition in Neo, I have a lot of ideas, but two of them are completely untouched. That being meeting room availability, which would take facial recognition with installed cameras in all of the meeting rooms and combine facial recognition with some sort of motion detection. That way we could see in real time which of the meeting rooms around the office were in use and also who was using them. This would display on some sort of UI. The second idea are gamification applications. The Nerf gun touched on this initially when people recommended that we crowdsource the targeting of the Nerf gun. The second gamification idea I have for this would be Office Tag using Neo. Neo can identify people in unique ways and then notify them they've been tagged, and they can choose the next target to be tagged. We carry around a lot of ways to be identified, whether that's from our key cards that can be scanned or faces recognized, or even something as crazy as vibration sensors in the floor that learn the walking rhythms of each individual. The last two ideas are sort of in progress. There's the Magic Mirror idea, which is a unique display that would populate based off of recognizing a user standing in front of it. Here someone stand in front and they can get something like Slack messages they haven't read throughout the day or calendar events they have coming up. The final idea is using this on the front door. So someone could walk up to the front door and a combination of facial recognition and a confirmation that their phone has been connected to the office Wi-Fi would unlock the front door for them. That way you wouldn't have to pull out any badge or key card to scan to get inside the front door. I know that this application of facial recognition in Neo can spark ideas for bigger systems in the future. While I'm here, I'm going to continue to use Neo to make these ideas concrete prototypes and always challenge myself to be creative. I learned a lot this summer, and I couldn't be more thankful for all the help that I received from just about everybody here.